and I am live. That is pretty cool. Today is 19th of September 2025, Friday, and let's just begin. I mean, I am late today also, but okay, I managed to get started, and that is cool. And yesterday I was looking up at a question which I was unable to do earlier, but now I got it in dynamic programming, which is this one. Two sets division. So in the first two cases, I got it wrong. And yep, the reason was matrix. The reason was we had to find modular inverse of the thing and then divide it. Let me show you exactly what I mean. Yep. Earlier here, what we had earlier was this res equals tab sn divided by 2. This is what we had earlier. And since this tab sn is modular, is a like modular value for something, and we cannot just divide in modulus like we can multiply and add. So here, instead of dividing this thing by 2, we have to divide by modular inverse of 2. And here above I have written a function which takes a number a, raises it to a power of b and give its modulo m. So we can say that int mod inverse for 2 is going to be power 2 raised to the power of m minus 2 modulo m. And why is this going to work, m minus 2? This is going to work because of Fermat's little theorem. This m number with which we have to find modular inverse for 2 is a prime number. And whenever you want to find, like if you have x as a number and you want to find x modular inverse, so that this thing returns 1 mod m. And if m is a prime number, then you can say x mod x inverse is going to be equal to x raised to the power of m capital M minus 2. Because from Fermat's little theorem, we know x raised to the power of m minus 1 returns 1 mod m. And we can write that left side like this: x into x power m minus 2. And this thing will return 1 mod m. And then we, and yeah, then we can just say that if you multiply x by this number, we get 1 mod m. So therefore, x modular inverse is going to be x raised to the power of m minus 2. And that is what we are doing here. And look at this. So earlier we had this, right? Or let me write both of them. Cout tab sn multiplied by mod inverse and take its modulus with m. If we take its modulus with m, this is what we will get. And yeah, let's use this for 10107. So this is what we were getting earlier when we were not dividing by modular inverse. But when we are dividing by modular inverse, this is what we are getting, which is the correct answer. So there is a difference. And there is also a trick which we can use to find modular inverse for 2 with any number, and I do not completely understand it, but let's see how it works. So yeah, here we just have to do mod inverse divided by mod inverse, or nope, multiply by mod inverse, my bad, into mod inverse and rest mod, take its mod with m. And this thing like works now. And also if we were to submit this again, this is going to work. CSES DP 2 sets C++20, and hopefully this works. Yeah, now this works because we are multiplying by the correct thing. Hello. Yeah, something came up, I had to go, and now it's fine. So see, now this thing is working. Yesterday, or yeah, the day before yesterday, when we were doing this question for the first time, it was messing up, but now it is fine. Now it is completely fine because we were dividing by 2. We had to divide by mod 2, and I used ChatGPT to figure this out. When are you gonna start CP sheet? I guess after I've gone through all of this, and yep, after I've gone through all of this, I would try to make the streams about CP sheet and everything else that I'm practicing on site. I will try to do that off the streams, because after dynamic programming, my goal is to focus on graphs and solve graph questions. There are quite a bit of graph questions. Yep. But for now, it is going to be dynamic programming. And we can start with a new question. But before that, yesterday, I saw a proof that specifically for mod inverse 2, where are you? Yeah, where I left exactly. I haven't done any question in the sheet. Here at 1500 level, I've only done 7 questions here. 6th one I was unable to do, and yeah, progress is 60%. That is fine, but now the remaining 40% is going to be exponentially harder than the first 60%, because they were easy, but now things are getting tougher, and I do not know how I was able to almost glide through 1400 rated questions. I think because I did study the basics of dynamic programming, that helped a lot in all of these questions. And now I want to have the same experience with 1500 questions, with 1500 level questions. That is why I want to complete, or not complete, but do as much as I can in dynamic programming, and also in graphs and range queries, and then attempt these questions being a little bit prepared. I guess I won't be struggling. Nice one. I'm almost at 1400, almost complete. That is pretty cool. Yep, you'll catch up in no time. Wait, I clicked somewhere. Yes, so yesterday, or generally, we have the formula. If I want to find with white color, if we want to find modular inverse of x with respect to some number m, generally using Fermat's little theorem, if this thing is prime, then we can say that this thing x inverse is going to be x raised to the power of m minus 2 mod m. This is the case generally. Yes, and the thing said, I was looking this up at ChatGPT, and ChatGPT said if I want to find modular inverse of 2 with respect to some prime number m, it is going to be equal to m plus 1 divided by 2 somehow. I don't know why this works. I guess the reason was that if I have 2 multiplied by 2 modular inverse, that is going to give me 1 mod m. This is the congruency, and yep, this is the congruency, and we can write this thing as x. So 2x 1 mod m, and if we take this thing to the left side, we can write 2x minus 1 0 mod m, and since modulus for this thing is going to be 0, it would mean that this thing is divisible by m completely and no remainder is left. Therefore, we can also write this as 2x minus 1 equals k m, because this thing is going to be some exact factor or exact multiple of m. So we can write this as this, and we can now solve for x, which is going to be something like x equals k m plus 1 by 2. And ChatGPT said that if we put k equals 1, this thing works, and then x would equal to m plus 1 divided by 2. And ChatGPT said that this thing only works, this shorthand only works when we are finding modular inverse for 2. No, I'm not really good with tree problems. And yeah, I'm not really good with tree problems. I haven't read about trees a lot. I've only read in graphs the first 2 chapters in the graph section in Competitive Programmer's Handbook. That is all the material that I have read on graphs. So I would have to work on that. And this thing is this, like, okay, if we replace 2 with any number, this whole thing should still hold, right? Right. For example, here we can say that when we took 1 to the left side, what we essentially did is we had some number modulus m on this side and some number modulus m on this side, and we subtracted 1 from both the sides, and it should still work, right? Yep, it should, this thing should still hold, even if we have something else other than 2 here. And then therefore this thing should still hold. There should be no problem with this. But when we are putting k equals 1, that might be a problem, actually. Wait, yeah, wait a minute, like literally just a minute, and I'll be right back. I'm like extremely sorry for this. I'll be right back. Okay, I am extremely sorry, and I am right back. Okay, let's get back to this thing, figuring out this thing. Why does this thing only work for 2? I mean, okay, so in this whole step, in this whole procedure, till this point, this exact point, I think everything is correct. Because what would be the argument against this point? And let's write this whole thing again with 2 replaced with some general number x, right? So we know that what we are looking for is this. This thing should return 1 modulus m. And we can replace this congruency symbol with equality symbol, and we can say x into mod x into x inverse mod m equals 1 mod m. Right now this equal is correct and we know how to handle equals, and let's say we subtract 1 from both the sides of this equal sign. So x into x inverse mod m minus 1 equals 1. And yes, we are going to be very mathematical and very precise, rigorous with this. So we have this thing and we have this thing, and we know that we can do subtraction and multiplication or plus in with modulus without any problem. And subtraction is not as simple as plus, but this is simple because we know that this value is at least equal to 1. So this thing, when we subtract 1 from this thing, it is not going to be negative, because it would only be negative if this thing is completely divisible by m, but it is not because of this, because we know that its modulus is going to be 1. So it would be no problem if we take this thing inside. X inverse minus 1 whole thing mod m should be equal to 0 mod m now, and 0 mod m is just 0, right? 0 mod m is 0, yes, remainder is 0. So we can say that this thing is leaves no remainder when we divide this thing by m. So this thing must be, this whole thing, x into x inverse minus 1 must be divisible by m completely. And if that is so, we can also say x into x inverse minus 1 equals k times m, where k is some positive integer, right? That makes sense. And after that we can solve for x inverse. So x inverse is going to be, and I do not know exactly where I'm trying to get at, but I'm trying to solve this, right? And I do not think we have made any mistake till this point, and this seems totally correct and reasonable. Every step makes sense, so this thing should also be correct. Now the question is, what value can we put in place of k? Yes, that is the question. What value can we put in place of k? And what value can we put in place of k? I think we would need some help here from ChatGPT or something. X inverse should be equal to k into m, the number with which we want to find the modular inverse for this number x, plus 1 divided by x. And the whole point depends on what we choose for k. And that would actually change the answer, because if we were to take 2, 3, 4 or anything instead of k, that would return different values for mod inverse. Let's say m is 7. Let's say m is 7. So 7 plus 1. If we put k equals 1, for k equals 1, m is 7 divided by 2, we get 4. And if we do multiply 4 2 by 4, we get 8. And that is, if we take mod 7, that does return 1. So that is cool. If we put k equals 2, and then we will have 7 into 2, 14 plus 1 divided by 2. 14 plus 1, 6, 15. That is not a integral value with which we can divide, but this is what we have. And yes, if we do multiply 15 by 2, multiply by 2, we get 15, and 15 mod 7 is also equal to 1. So this thing also works. That is cool. So why would not this thing not work for any other number? Let's say x equals 3 and m equals 7. Then for k equals 1, we will have 7 plus 1 divided by 3. And this thing is 8 by 3. And if you multiply this number, 8 by 3 into 3, this thing is 3 inverse. If you multiply this thing by this, we get 8, which is mod 7 equals 1. 8 mod 7 is 1. And for k equals 2, we get 14 plus 1, 15. 15 by 3, which is 5, and now this thing breaks. Shit. Now mod 7 is not anymore equal to 1. Mod 7 would be 5. 5 mod 7 would be 5. And this is kind of a research thing, I would say. Okay, let me pick this on my own of the stream. And for now, we will do some questions. Let's do this one. Counting towers. Counting towers. Your task is to build a tower whose width. Wait, I think we have done a question like this in CP31. I think it was putting. Okay, let me first read what this question is. Your task is to build a tower whose width is 2 and height is n. You have an unlimited supply of blocks whose width and height are integers. Width and height are integers. For example, here are some possible ways for n equals 6 when the we went to the wrong place. Yep. Array description. No shit. Counting towers. Yeah. For example, here is the solution for n equals 6. Some possible solutions. Okay, and we have an unlimited supply of blocks whose width and size are integers. Width and height are integers, and our total tower's height is 6 and width is 2. Given n, how many different towers can you build? Mirrored and rotated towers are counted separately if they look different. Okay. Okay. They look different. Okay. The first input line contains an integer t, the number of tests. After this, okay, we have multiple tests, it seems. We have 3 tests. Tests sign for 2. Shit. For 2 answer is 8. Okay, that would be easy to imagine. And then, okay. So let's see. What do we have? We have to figure out what our choices are at a certain point. For n equals 2, this is our tower, which is 2-dimensional. Like from here, this is our 2 by 2 tower. Yep, that is cool. So what are the ways in which that we can fill this? So, and in total, let's see. One way would be to just have one block in each of these. This is one way. Another way would be to have something like this. These two would be one, these two would be one. So that is 2 ways. Okay, instead of representing them like this, let's use one way would be to have the tower filled like this. Another way would be to have it filled like this. Third way would be to have it filled like this, and this is terrible drawing. And another way would be to have it filled like this, and another way would be to have it filled like this. And then also there are the mirror images. For this one, the mirror image would be this, and for this one the mirror image would be this. And then the last one, because the solution said that there are 8 possible configurations. Shit, yes, this itself would be a possibility. Yes, so there are 8 possibilities. That is nice thing. Hello. I really want to improve my math skills. For that, I am revising 11th and 12th concepts. Can you suggest some daily mock drills I should do to effectively improve? Okay, it would depend on the areas of mathematics that you are trying to improve. And okay, you want to improve your maths and you want some structure. I think you can pick any book and say that you are going to cover some certain topic or concept from that every day. You can create targets for daily or weekly targets and then commit yourself to doing that. That would be helpful. And for tests, yeah, just pick some book and start solving things and understanding things. That would be nice. That would be required for improving competitive programming. I would say you do not need 11th and 12th. If your algebra, if your this equation making is not pretty good, I would say then yes, go with 12th and PNC. Permutation. Okay, you can. I don't think you are going to improve your number theory by reading 12th and 11th concepts, but you can improve your permutation and combination from 11th and 12th books. But the problem with that is not the material that will be provided to you by the book, but the problem is the mindset. It is very hard for me to read from a school book, school textbook, and not think of it as if I'm preparing for an exam. So I would not suggest you use 11th and 12th school books because they have just certain amount of aura tied to them and a certain mindset that has to be there while you are reading that book, those 11th and 12th books. So I would say instead of reading, if you want to improve your permutation combination, you should first of all to select the topics that you want to improve. You will get to know the topics that you are weak in. And like you are saying right now, you know that your number theory is weak, your permutation and combination is weak, and there are also other things like probability which you are going to use, game theory, and therefore you can just select certain topics and start working on them. There is induction, recurrence, so you can just select topics and start working on them. And I would not suggest using a 12th book or 11th, any school books for that. And actually, when you have selected topic, how you are going to improve, you can, like for example, I have a book right here, a maths book. If I want to refer to something, I can use this one, Mathematical Methods for Physics and Engineering. This is a pretty nice book. If you want, you can download its PDF. Don't you No, I do not go to college right now. Like I have taken an admission, but I do not go there, and there is an attendance issue, but I do not care about it because there is no studying in college, no point in going to colleges. They do not teach you anything, and they do not rely on colleges. They are not going to help you in any way, right? They are literally not going to help you in any way. So just do not go to college. Yep. And I think I will take a dropout, and that is great, bro. Same shit, but I will try not to go to college more. Yep. I mean, there is literally no reason to go to college. And the only reason that it would be suggested to go to college is to find good people, people who are like-minded. And that is the only reason that you would need college for. And I think I have already found good people. I have good friends from my college who help me in things, with whom I can talk to. And now the college has served its purpose, and I do not need the college anymore. And I do not think anyone else also needs college other than finding good people. And if you have already found good people, then don't go to college anymore, right? Study at home and get a higher paying job earlier. That would be the thing. And getting back to the question, this thing. So we have to see how we can arrange things. This is the general structure, right? And when we will go cell by cell, and we will make choices cell by cell. Either we can make choices cell by cell. I think that would be more complicated, and instead we should make choices row by row, row by row. And we should be able to list out all the choices available, and they should be less than 8, because 8 choices are available when you are given 4 blocks, so there should be less choices. When you are at a particular row, let's say, which has 2 cells, then there are some choices, and one of them would be to make it a block, right? This is one choice. Another one, now we are trying to list the choices that we get. CHOICES. We are trying to list the choices that we get when we are at a particular row, because if we can list choices, we know that in dynamic programming the main thing is, at a step you have choices. And so yes, that is something that there is in dynamic programming. At a step you have choices, and you presume, and not just presume, you know for a fact that one of them is best, right? One of them is going to be best. So find value for all the choices, and then go with the best one, bestie one. Go with the best one. But here, our goal is not to find the best optimal answer. Our goal is to find the number of answers. So this step is going to be the same. And just that, after that, we have to see, uh, with every choice, how many solutions do we get? Then add solutions for all the choices, and then that's the answer. That is cool. That will be the answer. So first of all, we have to see what the choices are that we have, and then we will, some of our choices will hit edge case or base case, and then we will bounce back. Yep, that is the main problem. No like-minded people, they just mock when I do some CP stuff. CP means competitive programming in this context. Sam, there is no point in going there, right? This is negative effect. If they are mocking you, just wait and sit down and think about it. Is there actually anything that you are getting from college, or you are just going to the college because you are expected to go there, right? I would say make bold choices, choices that you are afraid of. And let's list down the choices. So first choice is this. We make this whole thing a block. And then second choice, yeah, that would be it. We make it a block. And second choice would be to make this a block, but leave it open on the top, right? So that maybe there are some rows on the top which might converge with this. So that is another choice. And then the symmetrical choice would be to leave it open on the bottom. Leave this thing open on the bottom so that this might extend to some bottom rows. And then the fourth choice. So at this point, we have exhausted all the choices which involve a block which covers both the things. Now, the only choices we have are to break this two blocks into two blocks, like so that we are not choosing a block which covers both the cells in this particular row. Now, this is another choice. We take these blocks individually and they are not open on any side. And now this has a few corresponding choices. One would be to keep this block open on this side, that is one, and or to keep this block open from this side, that would be one. Or shit, there is another choice in this, to keep this thing open on both the sides. Ah, my bad. Fifth choice would be to combine both of these blocks, both of these cells, and make it a singular block and keep them open for merging on both the sides. Hmm. Yes, and I hope I'm not making this more complicated. And then the same argument what would be here for this, and that would be, since this one is independently has three choices, to keep it open from top, or to keep it open from the bottom, and or to keep it open from both the sides. Three choices for this, three choices for this. In total, 9 choices. There are a bunch of choices. Shit. But in general, we can say there is a general choice when we are combining these two cells into one, and then there is a choice when we are dividing these two cells. I think that would be a wait, shit. If we do just say that is our only choice, either we combine these two cells or we leave these two cells separate, then what would be our base case? Hmm. This is some geometry shit we got here. Right. Yeah. Choices, choices. Okay. And the only thing that we get is the number of test cases and the value of n, which is the height of our tower. And since we are getting a lot of base cases, the answer for n is not going to change. So we will probably here have to pre-compute stuff and then answer every test case in constant time from the lookup table that we will create. Okay, so we have to write a recurrent function for this dynamic programming question. Let's say for Tn, no, let's go through the 4 steps rigorously, which we learned about in the CLRS book. And those steps are, first of all, describe a optimal solution. And I guess the problem here is that in that book, we learned about how to find the optimal answer, but not how to find the number of answers. Okay, so that is why I'm facing a bit difficulty here, and that is like, of course, I will face difficulty. And then the second would be to describe the optimal solution terms terms of optimal answer to sub problems. That is this thing. And then the third is just to find the optimal solution. And these are the steps when we want to find the optimal solution, but we do not want to find the optimal solution. We want to find the number of solutions. And therefore, these steps could be changed from optimal to correct or valid. Describe a valid solution, and then describe a valid solution in terms valid solution recursively. That is nice thing to say. Recursively in terms of valid solution to subproblems, and then find the number of valid solutions. Okay, so what would a valid solution look like? For the 2 by 2 grid, a valid solution could look like this. Wait, shit. Okay, let's say this is just okay, now I'm thinking in terms of where can I put these lines? Because that is literally the only thing that is changing. That is literally the only thing that is changing. And are these things independent? Okay, shit, wait. If n equals 2, this seems very easy now. Okay, if n equals 2, right? And this is the basic framework which we have, except of these inward concave corners somehow. This is the basic framework that we have, and the possible options for us to put these lines on are these. We could put a line here. We have one choice for that. So 1. We could put a line here, +1. And we could put a line on this side, +1. Or we could put a line on this side, +1. So in total, we have 4 choices. And all of these 4 choices are independent from each other. We could have we could have a line, or we could not have a line. In total, we have 4 independent choices. So and every choice has 2 possibilities, either to put a line there and to not, or to not put a line there. And in total, we have 4. So 2 into 2 into 2 into 2, which is actually 16 and not 8, which I thought should. So there must be some things which are repeating in this, and we have to cut them off. But I think that is a nice thing. Yep, I think this mental model is better than the one that we were using earlier. So let's actually write down all of these possibilities. 4, 1, 2, 1, 2, 3, 4. No, these are not actually independent. These are not, because I cannot have this line solely here. If I am putting a line here on this side, I must have either line here, either a line here or a line here. Yeah, so these are not totally independent. They are dependent on some things. If we have something like this and I want to put a line, let's say here, if I put a line here, then there must be, this cannot just be dangling in the sky. I need some line here, either here or on this side. And this seems eerily similar to a 3 blue 1 brown video which I haven't watched till now. It was a guest video by a nice guy. 3 blue 1 brown. This one. Yeah, this one. Exploration and epistemology, epiphany, this one. In this, yeah, this is very similar to this thing. This is, I would say these are, what is the specific term? These two problems are 62 likes. These two problems are, shit, what is the specific term? Not equivalent, isomorphic. These two problems are isomorphic. Yep. These two problems are isomorphic, I would say. That is, this, they can be converted into each other. That problem was in 3D, this one is in 2D. This should be relatively easy. And okay, now I do not care about how much time this is going to take. But you have to choose two 0 or 2 lines that you can choose in any number line. Yeah, it should be according to the height of the box. To choose 0 or 2 lines that you can choose in 0 lines or shit. Okay, I should not have read it, but okay, now I get it. Kind of. You are saying in a particular row, let's say in this, I either choose no lines at all, or I have to choose at least 2 lines. Right. And if I do choose a line, then that would also be counted as one of the lines for the next box. Mm, Okay, okay, you did give me a hint, but I will not think about it. Let me go from the line of reasoning that I was going with. Where there is some software update. Okay, it will be updated at night. So let's go from bottom up. And shit, now just what you said is going through my mind. Hello, came to say, okay, you are still in Japan. How is everything going? Were you able to find the person you were looking for? This is one thing we could go with. And wait, it might actually be evening or something there. Shit, now the tables have turned. I guess it is now later in the day. I also don't know. I'm just trying to solve with you. I don't know whether it is okay or what. Yep, let's figure this out. Let's figure this shit out. So this is one of the choices we could make. Something like this. Something like this is also valid. And also something like this. I think these are the only choices that we can possibly make. And this would also dep I think this would not depend upon what were the choices that were made by the row below this row, right? Because this thing, if I have a row in which this choice was made, I think I could have any one of these other rows as the bottom row here, and this is just now an independent instance of this other problem. So whatever choice I make here, I can make any choice on the top. Now, yes, I think that is true. Hey, yep. Sunday, I'll be returning to States. Yep, cool. That is pretty cool. It will be pretty nice to have you back. Yep, go ahead, shoot. Yeah, now the tables have turned. And time difference is 3.5 hours. This is actually cool. Fn equals Fn minus 1 into 3. Or also there is a choice of not making any lines at all. So into 4, there will be 4, right? So, and F, and our base case is when F equals 1, when we have one row, then the number of choices is going to be 2. And when therefore, then F2 would be equal to 4 into 2, which is 8, which is exactly the answer, 8. Let's go for 6. It would be like F 8, then 8 into 4, and this is F3, then F4, F5, F6. This is what we have to calculate. I stopped lead code though. I carried my laptop. Ah, you will get back to it in no time. I confessed to her parents and they know about it now. Bro is becoming a man slowly. From a boy to the man, kill the boy, Jon Snow. And I'm here from Pune and I'm 14 years old. Shit. And I am a coder. I am coder programmer. I make music with code in Python. Shit, something like Strudel and Visual Basic. I am also an animator. Can you guide me? That you, I guess you already know more shit than I do. But yeah, just since you are only 14 years old and you are not expected to have a job for at least 6 to 7 years, I would just say create things. You are like free to do anything. That would be the best thing you could do. Get into shit, try writing some programming language of your own, writing operating systems, start reading technical books, and just have fun. Have fun. That is the best thing you could do. Just have fun and spend time with computers and get better with computers. Mid-sem exam in 45 minutes. Bye. All the best. And that is cool. That is cool. So this is what we have. This thing is 16. This thing is 16. This thing, shit, 8 into 1. That is 8. Is 16 into 16, 256 into 8. Mental maths, some quick mental maths. That is 1000, 2000, 2048 something. Wait, if that is not 2864. Okay, I messed up, I guess, at some point. 250 into 4 is 1000 and 2000. 16 into 6. I think I got that also right. Into 4, into 4. Wait, shit, for the top part. Hmm. All the choices that I wrote down, like this one, or this one, or this one, or just this one where I don't choose anything. All of these, among these 4 choices, I can make these when I am in any of the middle rows, but when I am at either the bottom row right here, or if I'm at the top row, then the number of choices is going to change. So this formula, I would say, but if that is the case, then the answer that I got should have been higher than the actual answer. And this thing, shit, this is for 2. This is correct for 2. And if I multiply this by 4, this is for 3, 4, 5, 6. So that's row 4 into 4, 4, 4, 256. 256 into 8, that is also correct. 2048, which is just 2 power 12, I think. No, 2 power 11, 2 power 10 is 1048, 1024. So that is correct, this thing. And yes, 3 plus 4 plus 4 is equal to 11. So 2 power 11 is 2048. So the calculation is spot on, but the answer is not. Let's make our concept of making choices more concrete. If we are at the bottom row, then one choice is this, one choice is this, another choice is this, and another choice is this, and then the next choice is this. Shit. Well, not this, but keeping it open is one of the choices. But yeah, when I am at the bottom row. But when yes, I can make any of these choices when I'm at the bottom row. But when I am at the top row, like this is my top row, this choice and this choice, they are equivalent. Yeah, so one choice I can make is this, and another choice I can make. Yes, that is about it. That is just about it. Either to keep a line here or not. And it would only be possible in some cases when I have made some particular choices before. So I guess if we think about this in this manner, either I keep a line here or not. If I do keep a line here, then for the next, yes, now to keep a line here, the problem is divided into a few parts, I would say. One choice is just to put this line here, and another would be to not put a line for the nth row. And how old are you? 21? Yes, 21. Last I checked. Bro, this field is full of competition. Yep, this is full of competition. But if you are ahead of the competition, you are pretty well off, I would say. And tips for starters, just join the live chat. Live, what are you doing here? Yes, we are trying to solve this question, counting towers. And the main goal is to just be able to solve this question. For now, that is like very hands-on current target for this. I read no fiction and I have already made my own LLM, which is around. That is pretty amazing. Shit. Yes, me too. Me too. I'm also feeling inferior. Ah, shit. Yo, I gotta leave. See you soon. Get some stuff, today. I'm cooking, so need to make some prep. And Tokyo streets are way busy than I thought. Yeah, I guess Tokyo is the densest city in the world. So yeah, that is something you can expect there. Okay, so and for beginners, mm, any tips for starters? I would say you can go and take this course, CS50 from Harvard. It is free. It has lectures on YouTube and free exercises. And yes, you can take this. This is pretty cool for beginners and very, very good for beginners. You can go and take this course. This is pretty cool. This is what I did when I started coding. Shit. Do this in eating, in like cooking. I don't know about cooking. I can only cook instant noodles or rice, boiled rice. But if you want to get into programming, do this, right? or you were doing some Web3 shit and crypto things, Mesnier primes, uh, twister, prime twister, Mesnier twister, random generator engine is something like that. You were doing stuff already. Okay, let's say you are at the nth row. What would a valid solution look like? A valid solution would look like something like this. When you have a line, that line is complemented with some line either here, or either here. And if you have any valid solution which has some combination of these internal lines, these are not dangling, right? Something like this, like this, like this line has a friend, either horizontal where we have two choices, or vertical where we have only one choice, only one friend. Do you work? Nope, I'm not. Bro, you are way better than me in coding, no doubt. I wouldn't know. I wouldn't know. I mean, you are also younger than me, so I wouldn't say that I'm much better than you. When we are the same age, I'm sure you will be much better than I am currently. And no, I do not work, not yet. I'm planning to do something next year so that I can justify me not going to college. And yep, this thing, okay, let's go about this concretely. This is my nth row, right? And I have two choices. Choices that I have made, choices that I stand by. Walter White. So in one choice, I do here, and now my nth minus one row is this one above this one, and either I don't do anything here, and now my n minus one row looks like this. And yes, yes. So solving this thing would be relatively easier, because if we are saying fn returns the number of ways, then this thing is just equal to fn minus 1, because literally we haven't touched anything here, and we can just say our problem began at n minus 1. So this thing is easy to think about recursively. But here we have some limitations. Since we have this thing here, what are the next choices that we could make if we do make a choice like this? In the nth minus 1 row, if we make it more visual, we have this, right? So either we do this, or we do this, or the third choice would be we go with this. And this thing, this thing is an exact instance of this thing. And shit, this is just leading up into more choices. So I think thinking at level of individual lines is not pretty cool. And it's, yep, writing it, I made mine to go all into C no matter what the obstacles. Kudos to you. Go ahead. Maybe collab someday in some project someday. Yes, okay. And next year when I'm building projects would be nice. Main problem is timing, because US timing and your country timing are just completely mismatched. Yes, they are completely mismatched. Can you just teach me C, like, C++? I already saw all the lectures almost. That is pretty nice. If you have already watched all the lectures, then you should be like pretty well off than an average person. F3 shit is crazy to get something along. Problem is that we get some new tech every 2 to 3 months. So that is pretty nice. I mean, we are moving forward. I don't even know the basics for Web3, but yeah, next year I have a lot of plans when I have and sort of become comfortable with competitive programming, and I'm much better with competitive programming. Then I will have some confidence going forward. But for now, competitive programming for this whole year, for the rest of this year. But seems like it is not going well. Uh, okay. I guess breaking the choices down on the level of a singular line is not pretty cool. If we go bottom up, I think we can divide this whole problem into two states, and then we can use the four choices which we were talking about earlier. Like one choice is to just leave this as it is and not make any choice. And another would be to make something like this. Another would be to make something like this, or to make something like this. And we can break our initial problem when we are at the nth row. Yes, we can break. But when we are at the top, okay, we can say for sure that if f is the function, f1 is going to be equal to 2. Mm -hmm. Yes, f1 is going to be equal to 2, because when you have only one row, either you keep it as it is or break it into two cells. Those are the only two choices. So we can say this is our base condition, and then before that, I'm having trouble in defining this recursively. In one instance, we have made a choice like this, and in another instance, we haven't made a choice like this. And when we have made a choice like, oh, okay, shit, okay, if we think about, okay, so till now we were thinking about putting these lines on the upper side of the cell like this, or like this on the upper side of the cell. But let's say we are at some ith row, and let's say that these are not the choices which we have. The choices which we have are like to put something like this, or the mirror image would be like this, or not a mirror image, something like this. And this is our row. Our current row is like this. Okay, and another choice would be like just keeping it as it is and not doing anything. And this thing does not conflict or does not depend on the fact whether we begin with something like this or we begin with something like this. Because if we begin with something like this, we need, sorry, my bad. Yes, when we begin with something like this, we need to have either a line here or a line here or a line here. And so if we begin with something like this, then among these four choices, we can choose any one of these three choices. These are the three choices. We have three choices that we can go forward with. And if we begin something like with something like this, a plain thing, then our answer would be something like this. Then we will have four choices. Hmm, hmm, hmm. And we just have to make sure that nothing is overlapping. So let's go with our 2 by 2 example. 2 by 2 example, we know that f1 equals 2 because when we have a singular row, the only choices we have for, or we can even say f0 equals 0. And we begin with a base case, since we said we can begin with something like this. First choice could be this, or could be not making any lines. And when f equals 1, if we do make a line there, then we would go something like this. And yeah, we will go with something like this or something like this when we are not making anything. And we would do, I'm doing a very terrible job at explaining, articulating myself. And here f0 we stated here is 1, not 0, it is 1. So 1 plus 1 equals 2. And let's go general. Fn would be if n equals 0, 1. Otherwise, either we make that one singular line or not. If we do make that line, then the answer would be, in both the cases, we will be calling fn minus 1. If we do not make that line, then the answer would be fn minus 1. Yes, then the answer would be fn minus 1 if we do not make this line. And let's say fn minus 1 is equal to some number x. And this thing is going to include in the n minus 1th row 4 possibilities. And we know if we do not make this line, then we do actually have 4 possibilities. But if we do make this line, then we have 3 possibilities. And this thing is x. If we divide x down to each number of possibility, then this is the thing. And in total, if we combine making a line and not making a line, in total we will have, in a sense, 7 possibilities. So the answer would be 7x by 4, 1 into 7 by ah wait, should f0 is equal to 0, f0 is equal to 0, f0 is equal to 1, because if there is no row, then there is only one possibility, which is no possibility. possibility at all. Yo, you got choices within choices. Lol. Yes, plots within plots. And a little bit of basic GS. I get streamed apple. Yo, that is cool. I'll be buying a S11 Ultra Tab soon. New collection in my tablets. Just growing. Bro is growing. Plots within plots. That is a Dune reference. Okay. When we call shit. Okay. Shit. This is literally plots within plots. When we call fn this function is internally okay. We do agree when n equals 0. Let's not go to 0. Let's make 1 our base case. Okay. When n equals 1, then the answer is going to be 2. Right? And we can say that this function, when we call fn minus 1, this function internally is going to ask, is going to have two possibilities. One of putting a line, a vertical line, and one of not putting a vertical line at all. And in one case, okay, I think instead of thinking of just this is one possibility, this is one possibility, this is one possibility, and this. What the heck is this? Ah, no, I don't know what the problem was if we think about possibilities like this, like this. Ah, okay. Now I get the problem or nothing. So, okay, yes, these are literally the choices that we can go with. Okay, at every level we have 4 choices, and yes, then the number of subproblems we will call fn minus 1 function, which internally is going to make all of these choices and give us the answer. And we have our base case ready. When we have made this choice, then the next one could go with this. It could also go with this, or it could also go with this. But the thing is, I could only make this choice is only available if I made this choice earlier, or at least if I didn't go with this. If I didn't go with this choice. Yeah. If I have made this choice on the nth row, then on the nth minus 1 row, I cannot make this choice. I cannot make go with this. I can go with this though. So these two possibilities are eliminated in that case. Yep, these two possibilities are eliminated in that case. And so you can just take half of fn minus 1. Let's say fn minus 1 is x. So when we make this choice, we can go with anything we want. When we make this choice, we can go with anything we want. When we make this choice, all of the other choices are available. But when we make this choice, only two choices are available. And since in calculating x, we are going through all the choices. So answer would be x number of choices for this, x for this, x for this, and x by 2 for this. So in total 3x plus x by 2 instead of 4x that we had earlier. So, and we also have our base case, which is 2, then f n in general would be 3 f n minus 1 plus 3 plus fn by 2 plus fn minus 1 by 2, which is just 7n minus 1 by 2, which is kind of similar to what we were at earlier, 7 by 4 into x, cut it, 7 by 2 into fn minus 1. And for 2, 7 into 2 by 2, which is 7, and not pretty correct. That is wrong. Shit. Okay, let's do this Donald Knuth style. When we have two things, when we just have a 2 by 2 grid, let's cut this and be very professional. One is here, 1, 2, 3, 4, 5, 6. Wait, actual answer is 6, I guess, not 8. What the heck? That is witchcraftery. What the heck happened? Shit. What is it? That is actually witchcraft. Answer for 2 is 8. Okay. So there will be 8 possibilities to get this one right. 8 valid possibilities. So if let's list all of the bottom choices, the choices for n minus 1th row. For the last row, which is like just the second row. So with the second row, we could go with something like this, something like this, something like this, or we do not make any choice at all. And yes, yep. Those are the 4 possibilities we could go with. Those are the 4 possibilities. Then with each, with this one, I have among these 4, if I have already this, I can, okay, let's not think in 2 by 2 because we are hitting the base case already and we know the answer for that thing is 2. Let's go with the general case again. I'm messing this up a lot. Anyways, if you have made this choice, then what are the choices I have in the n minus 1th row? In the nth row, shit, okay. In the nth row, I have made this choice. This is the nth row, and in the nth n minus 1th row, this is minus 1. The possibilities I have are I could go with like this, the same thing, or I could go with this, or I could go with this, or I could just leave it open. So all the four possibilities. Wait, and these two are literally symmetric. So whatever the answer is for this, we can just 2x that answer and we get this thing, right? Okay. So for this, we have all of these possibilities. And when I go with this, how many unique possibilities do I have? In the nth row, we have done this. Then in the nth minus 1 row, we could go with this. We could go with this, or we could go with this, or we could go with open bucket. So here we have four possibilities. Here also we have four possibilities. Here also we have four possibilities. All of the four possibilities work, and let's say answer for these choices combined, this one and this one is x. Answer for this choice is also x because this n minus 1 row is not affected. But if we leave this thing open, if we leave this thing open and our nth row is here and n minus 1th row is here, then we cannot go with this. We cannot go with this, though we can go with something like this, have a line here, or not have a line here. So this is open casket. We do not keep a line here, and that reduces our options. Wait, shit, okay. Maybe, shit. I think the mistake lies in the fact that I considered when we have fn minus 1 equals x, then x is equally divided into four choices. This one, this one, this one where we have one line at the top, or no line at all. But it might not be the case. Maybe these three have the same probability of possibilities, and maybe this one doesn't. Yes, they do not have an equal share. So I cannot say that the probability or possibilities with this choice are exactly x by 4. Yep, that does make sense. So wait, shit, okay. Okay, let's cut it off. Let's divide this problem into two problems. This choice, there is this choice, and that is it. Let's say that is literally it. These are the only choices we have. And then with this choice, next we could have this choice, or we could have this choice. And when f, and same goes for this. So f n, if we are only considering these choices, would be f n minus 1 into 2, and the base condition would be when we are at the top, when f1 would be equal to 2, equal to 2, because when we are at the top, like when we are at the top, we cannot make this choice or this choice, these both of them, we can only make either not choose a vertical line or do choose a vertical line, this thing. And yeah, I think that is correct. And then we can write another function f dash n, where we are considering these choices, either to put a line here or to not put a line here. And since we have n is the total height, right? If n is the total height, we have 1 block, 2 block, 3 block. The thing is, we will have n minus 1 possibilities for choosing a vertical line or not choosing a vertical line. And then the answer would be n minus 1 power or 2 power n minus 1. And therefore, I would say, yes, therefore, I would say that total answer would be the sum of both of these functions. This is what we are after. This we can calculate recursively. Wait, we don't even need recursion here. For this part, we just do 2 power n minus 1. And for this part, we have this recursive formula, which we can just write in closed form formula. And we have our base case. Shit, if we want to write this in a closed form formula, 2 power n, because f1 equals 2, right? And 2 power 1 also equals 2. So let's, okay, that is our base case. And let's use induction. So our recursive function gives us this, equals f into 2 into fn minus 1. And we are saying that fn equals 2 power n. And using the inductive hypothesis, right, we can say fn equals 2 into n power n, 2 power n minus 1, my bad, sorry. This would be equal to 2 power n minus 1. By inductive hypothesis, we are saying that we have proved the formula works for fn minus 1. And if you multiply 2 into 2 power n minus 1, this would be equal to 2n, which is exactly equal to our closed form formula. So this thing works. Therefore, by induction, our inductive hypothesis is correct. So the closed form formula for this part is 2 into n minus 1, and the closed form formula for this part is 2 into n plus 1. And if we add these two things, let's say 2 power n minus 1, we take it common. Here we would have 2 plus 1, and 3 into 2 power n minus 1. Is that literally the answer? Let's check for n equals 3. For n equals 6, 2 into 2 power 5, which is 30. Nah, that is wrong. This thing is wrong. Shit, and yes, this thing is of course wrong. Of course, yes. This thing is wrong. Shit. For n equals 3, I guess, and these are the things that we have. If we already have the answer for n minus 2, right? We have all the possibilities. Okay, we messed up. Okay, we will use our correct formula to find the answer for n equals 3 when we have found our formula. So we bifurcated and we said this, and but the thing is this does lead, yeah, after making this choice we could go with this, we could go with this, or we could go with nothing at all. That is also a choice, or we could go with this. These choices are going to be entirely dependent. Shit. So this is one of the choices. This and this. And how much time has it been? 1 hour and 36 minutes. That is not pretty long. That is fine. I don't know the answer for 3. N equals 3. We will have to figure this out. If we say if n is our answer, then making this choice, our problems is just fn minus 1, right? We can make any choice we want. And for this also, our answer is just fn minus 1 into 2 actually, because there is also the mirror image for this one. But for this, what would be the sub problem that this problem depends on? When we call fn minus 1, it is internally going to make all of those 4 choices. Can we get some hint from this? Answer here is 2864. 2864. If we do factorize this thing, 2 and 2, 1, 2, 3, 2. This is very cowardly. 716 into 3, 5, 8. No, this is bad. This is very cowardly. No, we do not do that. This fn minus 1 is going to make internally all of those 4 choices, but when we are making this choice, we want to limit. We want to limit the thing. Three choices, 3 choices, 3 choices, 3 choices, 3 choices. or maybe our wait, if we go about this is nth row and two choices. We don't make a vertical line, we do make a vertical line, we do make a vertical line, and in the nth minus 1 row, n minus 1th row, if we do make a vertical line, then in this case, Fn just returns the correct answer, then how would Fn depend on Fn minus 1? How would Fn depend on Fn minus 1? When we know F1 equals 2, which is this and this F1. And then we have F2, which is, to state them again, this. Let's write them for if this is our first choice in the top row, then this is one thing we could do, this is one thing we could do, this is one thing we could do, or this is one thing we could do, and also this is one thing we could do, and shit, this is also one thing we could do, and then I hope I'm not repeating things here. I'm not. And then this is also one thing we could do. Yes, those are the all the possibilities when we do put a line there, and if we do not put a line there, and these are all distinct, right? Yeah, yep. All of them are distinct. If we do not put a line there, then we could go with this, or we could go with wait, we cannot go with this because these are blocks. We cannot have something like this. This is also not possible. This is also not possible. Shit. Okay. These are not possible because we do not have a L-shaped block, so-called, like this, which we can put on here. Right? We do not have something like this. So this is not possible. This is not possible. And this is not possible. This is not possible. So let's only write things that are possible. And yeah, line or no line. If there is a line on the top, then one thing we could do is make a horizontal line. Okay, cool. One thing we could do is extend it downwards. Okay, cool. And is there something else? Yes. Do it this way or do it this way. Mhm. Or make all the lines that there could be like this. So five possibilities right there. And are there any other possibilities when there is a line on the top row? I don't think so. And then there is this possibility. Then there is this possibility. And then there is one possibility where we are not putting anything anywhere. Oh, no, no, not master. And on code forces, not yet. No, not even close to a master. I guess a master has a rank of rating of 2000. Nope, not even close. I'm currently pupil. Yeah, pupil. Yeah, that is it. And that is why I'm having trouble. Oh, shit, I've been at this for 2 hours. So making, okay, let me do my best. Let me do my worst. F1 is 2, right? F1 is fast, F1 is 2. And then for nth row, we have three things which we could have, right? So this is independent, this is independent, this is independent. In total, 6 possibilities. And if we were to state all of these 6 possibilities, we would have nothing at all. One thing here, one thing here, one thing here, one thing like this, one thing like this, or one thing like this. 1, 2, 3, 4, 5, 6, 7 possibilities somehow. Because to have it or not have it, have it, not have it. 2 into 2. Oh shit, it is 8. It is 8. And one, so these are 7 possibilities. And also this one. These are the 8 possibilities. And this one has, let's say, internally this thing for this n minus 1th row. This would only allow this possibility. So this one has only one possibility internally, which is this one. And if we go with this one, then the number of possibilities that this is going to allow is we can do this one in n minus 1, this one, this. So four possibilities internally, four for this, because they are literally the same thing. And then this one could be paired up with this possibility, this two, three possibilities for this internally, because this or this, these are the three choices. I don't know, because three possibilities have a vertical line. And this one, nah, I don't think I'm thinking about this in the right manner. No shit, I totally messed up with this. No, no, this is wrong. This is wrong. This is wrong. This is wrong. This is okay. Okay. Uh, when we have something like this, let's say for n equals 3 and this is tilted, we either do not put anything or we put one line here, which is going to look like this, or we put one line here, which is going to look like this, or we put a line on both the sides, which is going to look like this. And now with that given, for wait, shit, okay, this gives us four possibilities. One, this, two, three, four. And internally in this, how many boxes do we have? We have only one boxes, so we have two possibilities, either to cut this like this or not to cut it like this, so two possibilities for this. And when we are here, we have two independent possibilities, to cut this one or not, or to cut this one or not. So in total we have four possibilities for this, and same for this, four. And here we have three boxes internally, and with each we have possibility for cutting this box or not, cutting this box or not, in this box or not. So 2 into 2 into 2, 8. So the answer for F3, if we ask for specifically, should be 18. I think we do not have an input for 18, but that is what we should have. Okay, so if we can find, okay, shit. I guess we are getting somewhere. I guess we are getting somewhere. I guess we are getting somewhere. If we just tilt the box. If we just tilt the box. Wait, okay, shit. I'm so stupid. Let's, whatever the answer is for this whole thing. Okay, I have answer for n minus 1, let's say, right? I have answer for n minus 1. There are like whatever it is. Let's say it is x, right? And and yes, for x, yes, if I have two choices. I do make a line here or I do not make a line here. If I do make the line here, then answer is going to be, if I do not make a line here, then answer is going to be exactly as x. Or if I do make a line in here, then there are going to be two possibilities. That is to split this or not. So if this thing is x, and if I do not make a line here, then answer is x. If I do make a line here, then for x, x, 3x. I think that is it. 3 into the earlier. Nope, nope, no, 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 no. That is not it, because we have f1 equals 2, and yeah, we have f1 equals 2, and in f1 we have these possibilities, either to make a line or to not make a line. And I'm saying when we add another row, okay, wait, I have to go to the washroom and I'll be right back in a minute. And I think I got this now. I think I got this, and I'll just get this right when I get back, and I'll be back in a minute. Just wait a second and I'll be right back. Yep, I am totally back. And shit. Okay, after laborious work, maybe I got this now. For n minus 1th row, there are two possibilities. And this is equal to x, right? And there are two possibilities. Wait. Yes, these are the boundaries, right? And whatever is there, we do not care about it. But what we do care about is half of the answers have a row here, a line here, like this, and half of these x answers do not have a line here, right? It is empty. And with these x answers, we have a possibility of creating a line here, right? So for this one on the left, what we will get, we have this, and we do create a line for this, and this is our last row. And in this case, we are increasing the number of columns by 1, right? Or we do not create a line, here. We do not create a horizontal line, and since we have a line here, we will have to extend this, and yeah, this would have no effect at all, and the answer would be x in this case. But yeah, but in this case, now we have a choice of putting a line here or not. Therefore, if we do put a line here, answer would be x. Answer would be 2x if we do put a line here. And in this case, when there is no vertical line, we either put a line here like this, or we do not put a line here like this. If we do put a line, if we do not put a line here, then the answer is just going to be x. But if we do put a line here, then we will have a possibility of putting something like this. So 2x, so in total 2x plus 2x plus x, 6. Nah, that is wrong. That is wrong. But whatever the case, we have a possibility of putting line here or not. So 2x for that. If we do put a line here, then we are increasing the number of compartments, you would say. And there we have a choice of putting a line here or not. But when we are not putting a line here, then we don't have any choice. We cannot do anything. So x cases would not have a line, but x cases would have a line. Shit. For this, I guess my definition for n minus 1 is wrong. It is totally wrong. For n equals 1, f n f1 is wrong. No, no, no. It is right, and it is raining. That is cool. Yes, it is correct. It is correct because this thing is supposing for f1, f1 is supposing that there is nothing in at the bottom. So we have this two possibilities, this or this. And when we have this and we do extend this below, either we put a line here or we don't put a line here. And if we do put a line here, then we have two possibilities. Either to put a line here or to not put a line here, right? And if we do not put a line here, then we do not have any choice. We didn't increase the number of compartments, the number of vertical compartments, you could say. And when we are here, if we do put a line here, yeah, so yes, we are going to count the number of leaves in this tree, you could say. When we do put a line here, and we know that the number of leaves here was 2, then how many leaves would there be for the next one? Okay, if we do put a line here, then this gives rise to two possibilities. We do put a vertical line or we don't put a vertical line, and there is also the possibility of not putting a line at all. So initially for f1 we had only two roots, you could say, and then that led to us having 1, 2, 3, 4, 5. 6 is not the right answer. Shit, 6 is not literally not the right answer. is that also makes sense because we are not considering something like this, right? Yep, something like this, and the mirror image. Should these are the only things that we are not considering. Okay, and these are only possible when there is a line. So when there is a line like this, there is also another possibility of not cutting this completely, but partially. And there are just two possibilities for that. Either, since there is a line here, we could do something like this, or we could do something like this. A line here and here. So in total, we have 8 leaves now, and let's actually count how many of them have a vertical line and how many of them don't. So this one has a vertical line 1, 2, 3, and 4, and 5. 5 of them have a vertical line while 3 of them do not have vertical lines. So we cannot say the ratio is 50-50. That would be wrong. This one has a vertical line, this one has a vertical line, this one has a vertical line, and this one has a vertical line, this one has a vertical line. In total, 1, 2, 3, 4, 5. There are 5 vertical lines. And one vertical line gives rise to 1, 2, 3, 4, 5 possibilities, and no line at all gives rise to 1, 2, 3 possibilities. In total, 8. So can I confidently say that when I have Fn minus 1 equals x, no, we cannot confidently say that how the answers with vertical lines and no vertical lines at all are divided. So I guess we can return two things, x and y, the number of possibilities which have vertical lines and the number of possibilities which do not have a vertical line. And in that case, f1 would return 1 comma 1, and we can say then f2 is going to have 5 comma 3, and then f3, yes, 5 possibilities have a vertical line, right? Yes, 25 plus each. Okay, each one of this possibility when we have a vertical line gives rise to how many vertical line possibilities? 1, 1, 2, and to just bifurcate this thing, cut this off from here. So let's say x is the number of possibilities which have a vertical line, and y is the number of possibilities which do not have a vertical line, and from each of this x we get 1, 2, 3, 4 vertical lines. So in the next iteration, we will have 4x vertical lines from vertical lines. And when we do not have a vertical line, then each no vertical line returns one case, like one case in which we do have a vertical line. And this would be the number of possibilities which do have a vertical line, and the number of possibilities which do not have a. So x dash, the new x that we return would be 4x plus y, and then y dash would be, since each x, how many possibilities does it return where we have 2 and what 1 2. Okay, I am some things in the way. 1 2 3 4, only one, yeah. So y dash would be x plus each x is giving one possibility where there is no vertical line, and each y is giving two possibility where there is no vertical line, so 2y. Therefore, and the total answer would be x plus y for any case. So f n, what if n equals 1, then return 1 comma 1, otherwise return. Okay, let's use this. Shit. Okay, hello. Shit, Arvind Kejriwal is. Hello, how are you? Fn, and that is very small. Fn would be equal to, if we have n equals 1, then we will return 1 comma 1, right? Okay, but when n is not equal to 1, we will return the new x dash. Where is dash? X dash is going to be fn minus 1 dot x into 4, and not Siri, plus f n minus 1 dot y. Yep, and then x plus 2y. Y dash is going to be f n minus 1 dot x plus 2 into f n minus 1 dot y, and then return x dash comma y dash. I think that is right, and hopefully this works. Okay, let's write this down for first some values. We know f1 equals 1 comma 1, right? We know that, like, just from brute force. And then f2 would be equal to 5 comma 3, and then f3 would be equal to 4 into 5, that is 20, plus 3 23, 23 x dash, new x would be 23, and the new y would be 6 plus 5, which is 11. Yeah, So 23 plus 6 plus 5, 11. Yes, and therefore here the total answer was 2. Here the total answer is 8. And then here the total answer is 34. Okay. And then F4 would be equal to 5 into this number, which is 115, 115 plus 11, 115 plus 11, 126, comma 11, 22, 22 plus 23, 45. And if we sum both of these, we will get 171. I think that is right. And then F5 would be equal to this number into 5. Okay. 150, 600, 630, 630 plus 45, 675, comma 20, 90, 90 plus this 216. And the summation of these two would be 8, uh, um, 891, 891, I think. Then F6, 6. Okay, yeah. If this thing is correct, if our recursive formula is correct, we should get this number 2864. Okay, 202864. This is what we should get if the formula is correct. And let's see what do we get. So this number multiplied by 5. Laptop is going to die. 675 multiplied by 5. Shit, that is way over the limit already. Shit, I missed. Fuck. I missed up. Why was I multiplying by 5? Because x dash shit, why was I multiplying by 5? X dash equals 4x plus y, not multiply by 5. Shit, okay. X equals x and y dash will be equal to 2y plus 2y. Shit, 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 shit. Okay, these things would be wrong then. This thing is correct at least. Yeah, and f3 therefore would be equal to 20 into 4, 20 plus 3, 23, 23, and 3 to 6 plus 5, 11, and the sum would be 34. Sum would be 34. Okay, and then F4 equals into 4, 80, 92 plus 11, 103, 103, comma 22 plus 23, which what is 22 plus 23? 34. That is a coincidence, I would say. That is not, because this is wrong. It is 35, right? 22 plus 23 is 35. My bad. Shit. Okay. Now it is correct. And 80, 92, 92 plus 11 is 103. That is correct. And 22 plus 22 plus 23 is 45. And the sum would be 148. Okay. And then F5 would be 412, because into 4, 412, 4, 5, 7, comma 193. Okay, cool. 193. And here we have 0, 1, 10, 5, 4, 5. 560. Okay. And then F6 would be equal to into 4, 90, 900 into 2, 180, 180 and shit. Okay, I will do this in my head. I'll do this in my head. Yo, hello, Eric. We are trying to solve this question for the last 2 hours. This one, counting towers, and I think this is the general formula where X is the number of possibilities in the above row. Like, uh, if I am at the nth row here, then X and my fn function will return two numbers x and y, where x is the number of possibilities which have a line here, and y is the number of possibilities which do not have a line here. And then there's this recursive formula to calculate the next x and y. X and y are the values for fn minus 1, and x dash and y dash are the values for the current n. And that is what I'm trying to calculate here. And now is the moment of truth. If this, and I know, I guess this is not the optimal way. I think there might be a better way, but this took me 2 hours. This is the only problem that I have done since the stream started. Not done, but in the process of doing. And I want to get this right. So now into 4, 900, 180, 1828 plus 193, 182, 1928 plus 93, 2078 plus 3, 2081. I think that is right. And then the new y value would be 456 plus 300 plus 38 386 386 386. I do not want to write this down, just do it in my head. 386 800, something like 8. Should this might actually be, nah, this is already going over the limit because I think I'm messing up. I might be messing up with my calculations. Let me write this down. Shit, that is some new thing. What is the maximum n? The maximum n is going to be 10 power 6. Okay, yeah, cool. Okay, and vector integer answer size would be I want to power 1 power 6. Yeah. Const n m equals 189 plus 7, and const n range is 1e6 plus 1, let's say. And then for not this but a pair int and answer 0 dot first equals answer 0 dot second equals 1 and wait no for n equals 1, and then for int I equals to I less than n I plus plus, not less than but even at some cases equal to n, then answer uh, I dot first is going to be answer I minus 1 dot first into 4 into this plus answer I minus 1 dot wait auto x comma y equals answer I minus 1, then answer I dot first equals 4 into x plus y, and also answer I dot second equals x plus 2 into y, and then xi dot first modulus with m, and answer I dot second also modulus with m, and here C out answer n with any lines. Not declared in this scope. The hell, yes, of course not declared in this scope. Uh, okay, shit. Okay, my bad, sorry. Dot first plus answer n dot second, and this might like overflow. So let's also take modulus and less than range. Negative. Wait, we got this. It is working. It is working. It is working. It is working. After 2 hours, 2 hours and 29 minutes, 5 seconds, 4 seconds. Uh, removing towers. What is the name of the question? Counting towers. Counting towers. Counting towers. Okay. Submit. Uh, we can move to the next question, I guess. Ah, shit. Let me write this down again. Okay. Drink some water. Fetch some grass. It is working now. It is working. Okay. Shit. Const int range range is going to be equal to 1e6 plus 1. Okay. Because maximum value of n can be equal to 1e6. Then const int, that is not const int m is 1e9 plus 7. That is the we have to take modulus. And then internally we will first pre-compute the answer for everything. Int pair int Okay, integer, this is going to be called res, and size is going to be equal to range, because we are pre-computing the answer for everything, and the answer is going to be equal to res f of n. Answer for any n is going to be equal to res n dot first plus res n dot second dot second, where res I dot first is the number of possibilities having a vert vertical line in at the ith at the bottom ith th ith ith row, where and not second is the number possible. Okay, I'm messing up. The possibility is having no vertical line at the bottom I row. Okay, with that, let's pre-compute, and we know res1 dot first equals res1 dot second is equal to 1, because when we have only one thing, when we have only one row, the only two possibilities, in one possibility we do have a vertical line, in the other possibility we do not have a vertical line. So res1 first part in the pair is going to be 1, and the second part in the pair is also going to be equal to 1. So that is our base case, and then we will take it up from there. For I int equal to 1, I less than range, I plus plus, and let's say auto x comma y are the first and the second values from the last response, I minus 1th response. Now we have to update values for the current response, and it is going to be res. The first value is going to be equal to 4 into x plus y, and res dot second is going to be x plus 2 into y, and after that we will also have to take modulus mod with m and res I dot second also modulus m, and let's make these things a bit bigger than a long than our integer, and make them long. Now it is cool, and you might ask why this particular configuration of x and y. That is because here we like went through the things at some point. Yes, here we went through all the possibilities that there could be, and we figured out what are the plots within plots. If I have x number of possibilities in which there is a vertical line here on the last row, and I have y number of possibilities in which I don't have a vertical line, then how many of these x possibilities give rise to new possibilities where there could be a vertical line, and we saw that it is equal to 4x, and each one of these y possibilities where there is no vertical line, we saw that all of them give rise to only one possibility where is a vertical line on the current line. So therefore it would be equal to just the next x dash would be equal to just this thing, 4x plus y, and the remaining possibilities are like we do not have any vertical lines at all, and these are given rise to by these things like this, right? And yeah, after pre-computing the answer int t, c in t the number of test cases, while t minus minus int n, c in n, and c in n, and c out, just output res I res n dot first plus res n dot second, take mod with m and new line. Okay, does that work? Yeah. Yes, it does work. Shit. Const constant m equals 1 e 9 plus 7. We win these. Okay. Yep, we do win these. Okay, let's submit again and see. Oh shit. My bad. Sorry. Nice. Hello. Help. Yes, help. Are you able to read the chat? Yes, I am now able to read the chat. Hello. Mute is Dr. Room. Yes, do not spam anything. Can you see he is writing code right now? Yes, I was. Hello, and now I am listening whatever you have to say. And yes, do not spam. B vibe, D vibe. And okay, so you want to start programming. There's just the same thing, one thing which anyone can do when they are starting CSFT. You can take this course. This is free from Harvard and literally free. All the lectures are on YouTube and there are also exercises. Shit, you both had the same question. Yeah. Start from this. And wait, what do you specifically want to start? Do you want to start programming or do you want to start competitive programming? If you want to start programming, then go with this CS50, take this course completely, like understand everything and that is in this course. But if you want to start competitive programming, then with DSA, I would say you can start doing competitive programming. DSA completely, okay? Then competitive programming would be nice. Right, this is complete or competitive programming. Whatever the case, you can start with this CP31 sheet. Yeah, you can start doing competitive programming if your goal is just to get better at DSA. You can start doing competitive programming. You can go to this sheet and start solving questions, figure out things. I mean, for the first few problems, you will just struggle, and not just for the first few problems, you will struggle throughout this sheet, beginning from 800. When you get to 1900 rated questions, you will struggle throughout, and you can begin your journey from here. And you do not have to have a well organized plan just when you start. You just start and things will make sense as you keep going forward. And let's submit again. I want to just see green again. Counting towers. That was cool. That was cool. That was literally pretty cool. Accepted, accepted, accepted. Okay, what is the analysis? What is the analysis? Share the sheet link. Okay. And if you go to the description, there is also a Discord link which you can join. And there are more resources in that Discord server. I would say, yeah, you can join that. Shit, I'm promoting self-promotion. You can join the Discord. Shit. Harsh, reply to him. He's trying to help you. Why are you not replying? You were saying a lot of things before, but now you are. Okay, okay, okay. My bad, my bad. To solve solution one. Okay, there are a couple of solutions, I guess. To solve this problem, using dynamic programming, the choices of state space is not obvious. Yeah. For example, using only the height of the tower as n. Yeah, yeah. Yes. How do we define a state is something. Yes. For example, using only the height of the tower n as state does not seem sufficient. A solution could try to split the tower into two pieces with heights a plus b equal n. Okay, but towers which cannot be split also exhibit complex patterns and are hard to count. Yeah, their intersection, I guess, at their intersection. This suggests that information some more information about the tower needs to be encoded in that state. And I'm still very happy that I got this right. Okay. Yes, okay. So just defining a state with the height of the towers is not sufficient. We need some more information. That is what this thing means. One suitable state space is determined by the height of the tower and whether or not the topmost two squares are disjoint. That is exactly what the information is that we are passing down. Mm, Having a vertical line just means if there is a vertical line, then the above row has disjoint sets. Yes, has disjoint sets, and if there is no vertical line, then the last row has non-disjoint sets. Yep. This suggests that yes, that some more information is required. One suitable state space is determined by the height of the tower and whether or not the topmost two squares are disjoint. In other words, whether there is a line drawn between the squares. Let the function towers Si describe the amount of towers with the height I, where S as 0 or 1 indicates the topmost squares are disjoint as 1 and not disjoint as 0. Define towers with height 1. Yes, with this. Okay, yes, 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 yes. Mm-hmm. Two 1 by 1 block towers and two towers would be one. Yes, okay. So they are saying to create matrix chain a table like this with a split, and this is I, which is the height of the tower, and maximum is n, minimum is 1, and here we have 0 and 1. 0 indicates there is no split, and 1 indicates there is a split, and how many possibilities there are. For 2, yep. And let's say this is x, and this, let's say this is x and this is y, then we can fill the next row. We can fill the next row as 4x plus y and x plus 2y, which is exactly what we did here. I think that is the conclusion. Then 4 plus 1 and 1 into 2 plus, yeah, that is one solution that you could go with. Okay, let's read this completely. One suitable space is height and whether they are disjoint or not. Okay. Base case is towers 0, 1, and 1. Okay. Now let us explore the transitions between states in which height I minus 1 and I. How many ways are there to add one layer to a tower in each case by starting new blocks or extending existing ones? When s equals 1, there is a split. When x equals not 1, then there is not a split. And they are saying how can we grow this thing upward? So we can grow it like this or like this. And yeah, it's like the same thing, but with different notation. For each split, it returns 4 possibilities in which we can split the current row, and 1 possibility in which we do not split. And for no split, there is 1 possibility in which we do make a end up with a split in the current row. And if there is, and 2 possibilities in which there is no split. Okay. The implementation flow pre-computes the values for all the things. So each test case can be answered efficiently. And this is exactly what we did. This is exactly what we did. Okay. Solution 2. Despite it seeming challenging, there is an explicit formula for this. Okay, so there is a closed form formula for this. Let's try to get at it. What is our recursive formula? Let's just use this thing for a couple of things. Int I equals 0, I equals 1, I less than 5, I plus plus. Not 5, let's say 6, or let's say for I till 11, C out, res x is res I dot first space comma y space y res I dot second and space. Okay, we also should have plus there. Yeah, let me have a plus instead in the middle. Okay, x plus y equals res I dot first plus res I dot, and here we also do not have take modulus because res I first and second are not going to be very big for the first 10 numbers, or it might actually be very big. Shit, it might actually be very big, but we are using long, so that should be cool. G++, counting towers, dot slash out, and okay, so these are the things. And is there some pattern? That is what we have to see. Yo, where is all? Okay, I'm using Vim. You can look it up. There is this program which you run in the terminal, and you can use it to write code. And pro programmers use Vim, right? I want to become a programmer, and if you want to become a programmer, use Vim. Okay, and then you can flex on your friends when you use Vim. That is the benefit of using Vim. You can flex. And yeah, that is one of the benefits. And let me switch up the order on this thing. Plus this, yep, and keep the plus or flash out. Okay, so is there some pattern? And okay, so now what I'm trying to do is, since we know what the recursive formula is, which is this thing, is there some closed form formula which we can use here? Because here in the first line, they are saying there is an explicit formula for this. So let's just try to find it. Not that code currently, not. Keep grinding, do not stop. Right, right, don't stop. Mm, You mean physically where at my home? But if you mean like softwareically where it is, this is terminal. Ah, okay, yes, this is terminal. I guess, okay, yes, shit, I didn't know anything when I was a beginner. This is a program called terminal, and I guess it will be much better if you look it up. Yeah, software is terminal. And is there a better description? Uh, yes, this is a software called terminal which you can use to interact with your computer. Normally, when you use your computer, you use icons and mouse and like this. But there is also another way to interact with your computer that involves writing code. ls like this, and htop if I have htop. Yes, this is another way to interact with your computer, and this thing has to do with just the keyboard, and you can do anything you want in your computer using the keyboard, and you do not use mouse. And this is how things were before there was a mouse. Apple introduced a mouse sometime later, but before that people used to interact with the computer using just the keyboard, and there was no mouse. And this program is just like that. We can interact, we can copy files from here or there, we can play something, we can start some program. And yes, we can also start some programs. Like normally when we want to start, uh, yes, the software that I'm using in the terminal is called nvim. And to start neovim, and to start that you just write nvim, and it starts. Now the program has started and I can use this to write code. And how can I use this to write code? There are like, you will have to learn how to use neovim. Neovim. Okay, shit. Okay, my bad. Sorry. This is neovim. I guess I said that the first time when you asked this question, but yeah, this is neovim. I'm using neovim. Uh, Emacs attach TCP. Okay, and I'm also using TCP. Not TCP. I'm using Tmux to have multiple sessions like this. There are multiple sessions. If I want to go in the and setting the settings which I use for giving contest, there is another session for that. For DSA, there is another session. There is a session for GDB, which is GNU debugger. For CP, competitive programming. Yeah. So Tmux with NeoVim. That is the thing. And now, what could be the pattern here? Shit, I don't know. What is the pattern here? Yep. You're welcome. Shit, that sounded very rude. No, thank you, thank you. Saying you're welcome, it sounded very, very rude. Shit, my bad. X and Y. For F1, we have 1 and 1. For F2, we have let's say X and Y. For the next X, it is equal to 4x plus Y, comma, uh, 2y plus x, and then cut this. And then for the next one, next x will be equal to 4x, 4 into 4x plus y plus 2y. Okay, yeah, x dash equals 4x plus y. Shit, HTML. And y, and also y dash equals x plus 2y. And IDE, VS Code, cursor, trade, should throws into too much things. Okay, and let's say x dash dash would be equal to 4 x dash plus y dash, and then y dash dash would be equal to x dash plus 2 y dash. And I suppose we agree on what we are trying to do here. We are trying to find a closed form formula for this recursive formula. And now let me put values for x dash and y dash in this, and that might help in some way. So 4 bracket x dash was equal to 4x plus y dash is x plus 2y. That is the thing. And if we take this further, then x dash dash would be equal to, in total we have 17x plus 3y, and in here we'll have y dash dash equals 4x plus y plus 2x plus 4y, which is just y equals 6x plus 5y. Okay, so we have to see how these numbers are increasing. 17. Let's go one step further. X dash dash equals x dash 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 equals 4x dash dash plus y dash dash. And yeah, let's go with that for first. 4 into 17x, it is being multiplied by 4. 4 into 17x plus plus 3y from here. And if we extend that, y equals 15, 30, 60, 68, 68x plus 12y. Oh shit, there is also plus y. My bad. Plus y dash dash, which is 6x plus 5y. And if we add 6x plus 5y, if we add 6 to this number, we will get 74, 74. And if we add 5 to this number, we will have 17. And here y dash 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 equals x dash dash plus 2 into y dash 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 equals 17x plus 3y. I can write it directly. What is y double dash? 17, 10, 12 plus 17, 29x plus 3 plus 15, 18y. So is there a pattern? Is there a pattern? What is 17? No, 17 square is a would be a big number. What is 4 into 17? Yes, 4 into 17. 4 into 17 would be 68. Yes, like we calculated earlier. 68 plus 8. 68 plus 6. 4 into the original value, initial value, which is 1. First we added 1, then we added 6, and then what do we add? And before that we added 0, 0, 1, and then 6. And okay, let's go one more step, one more step, one more step. What the hell is that? Line size 2, x dash 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 4 dash equals 4 into 74 x plus 17 y plus 17. It is depending on the last x and y values. Okay, I don't know how to calculate the next formula. 17 plus 6y, this one. X dash dash equals 4 into 4x plus y. So 4x from here, 16, and plus x plus 2y. Ah, yes, yes, it is 6. It is 6. Okay, my bad. It is 6. And now, since this is equal to 6, then I messed up with all of these later formulas also. I think this one is correct, which is just this thing, 4 plus this into 2, 6. Yes, and plus this 5. Yes, okay. And then here, x dash 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 equals, and thank you for the heads up. 1768 plus 6, 74x plus 6 into 4, 24 plus y, 29 y. Y dash 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 equals, should I guess this whole stream is going to be about single question? Yes, it's been already 3 hours. Anyways, here 12 plus 17, which is 29x plus 5 plus 10 plus 6, 16 y. And let's go one more step further. Dash 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 equals 74 into 4, 280, 296, 296 plus 29 plus 25, 325, 325x plus 29 into 6, 30, 174, 174 plus 16, which is 190 y. Okay, and how many y will we have? Y dash 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 equals 258 plus 74, 62. Yes, yes, that should be correct. 32 plus 29, which is just 61 y. Is there a pattern? I don't see a pattern. because this value here 325 depends on this and on this, which depend internally on the previous two values. Let's just read the thing. Solution 2. Despite it seeming challenging, it does seem challenging. There is an explicit formula for counting towers which cannot be split further. Okay, such a tower consists of either 2 by n blocks or 2 1 by x blocks. Okay, despite it seeming challenging, there is an explicit formula for calculating towers which cannot be split further. Where block boundaries do not coincide at any height. In the later case, there are 3 possible configurations at each intermediary height. Neither of the columns have okay, they do not have a diagram for this one. What is their formula? Towers I equals if this thing depends on the last 2 answers. Okay, there is some maths. Okay, I can get into that on my own at some point, but yeah, but we did make progress here, so that is good. We were able to come up with this solution. That is very worthwhile. And I do not know how were um, this many people able to do it, but okay. Now this one, a removal game, or maybe this one, projects. Let's do removal games. There is a list of n numbers and 2 players who make moves alternatively. On each move, a player moves either the first or the last number from the list, and their score increases. I literally feel like I have done this question. Both players try to maximize their score. So they would, what is the maximum number of maximum possible score for the first player when both the players play optimally, and they have given us a number. Okay, greedy. Nope, shit, I've done this question in, I guess, in the CP31 sheet, this exact question, and it would be funny to see if I am able to do it now. And shit, I think you again messed up. Shit, my bad. 325 plus 103, why? 325 plus 103. Y would be here, y would be this thing into 6. 103. This thing into 4. Wait, 103 is 103 would not be the answer, I think, because we multiply the earlier x by 4, which means we multiply 29 by 4, which is 116. So 116 y from this side. I mean, yes, 190 is wrong. 190 is way too much, but okay, we will get 116 y because 29 into 4 is 116. Yes, 20. Yes, 29 into 4 is 116, and we add 16 from this thing. So plus 16y, which is equal to 132. Wait, what? Yes, 132y. So yeah, this thing is wrong. This thing is wrong. This thing is wrong. 132. Yep, cool. And okay, now for this one, they have to play optimally and do their best. Print the maximum possible score for the first player, and the first player goes first. Here, let's do CSC. int n, c in n, and then a vector integer, let's call it a, for int reference x and a, c in x, and n is not very big actually. For int I equals 0, I less than n by 2, I plus plus, either I choose something from this index or from the other one, or this thing is not right, and L equals 0. L and R are pointing to the best thing I can have right now. R equals n minus 1, and do this while if n is even, then they will have the same choices. And when n is even, let me see, when n is even, let's say it is equal to 1 to 4, this one gone, L will become 1 and R will be 3, then I take, let's say this, R will be 2, and someone makes this choice, they will be same, so let them make choice, and yeah, they will be same, and when I make this choice, L or R, one of these will go out of bounds, and okay, that is cool. Either L will go to the right of right, or R will go to the left of L, and we will terminate. But if there are three possibilities, L is 0, 1, 2, or 3, 1, 2. If I, let's say, choose this, then L will become 1 and R is still 2. Then let's say I choose this, they are same now, and one of them will make a choice. Okay, so this will go while R is greater than L, greater than or even equal to L. Yeah, I think the table would look like something like this. Pair in yes, response size n plus 1, just in case. And okay, what does this even mean? Sure, this would be very hard to describe in tabular form. Removal game. We have something like this. Here the correct output is 8. How would we get 8? Uh, Here we have Alice and we have Bob. Let's write the indices of the numbers that they are choosing. Yo, what to do if you want to start? What resources? Uh, for theory, you can go with, or you should go with, I would first of all suggest that if you want to, okay, you did say CP. So for competitive programming, you can use this book, Competitive Programmer's Handbook, and I will not boggle you down with more resources than this. So for theory, you can do this, and for questions, you can do CP31. And these two things should be enough to get started. They are enough to get started. And yeah, these are what you can start with. That is what I suggest. So Alice, let's say, chooses the one at index 0, or write down the actual numbers that they are choosing. Alice chooses 4, then Bob would choose 5. Alice would choose 3 then, and Bob would choose 1, and they are not well off, so that is wrong. Let's say Alice chose 3 first, then Bob either chooses 1 or chooses 4. He, if he chooses 1, then Alice will choose 4. and then Bob will choose 5. So then the score would be 6. But if Bob goes with 4, then Alice will choose 5 and her score would be 8. And Bob will then have to choose 1. So that is bad. So Bob would go with 4 and Alice would not get a, no one would get an output of 6. So I guess Alice going with 4 for the first time was good. And now Bob has a choice either to go with 3 or with 5. If he goes with 3, that would be bad. Shit, how are they even getting to an output of 8? If Alice goes with 3, then she needs 5. Shit, she will get 5 no matter Bob goes with 1 or 4. She is going to get 5. Bob, let's say, chooses 1 or anything. He can choose 4 or whatever he wants. And Alice will choose the 5 because now 5 is open, and then Bob will choose the remaining number, which is 1. And here answer is 5. Here answer is 8. 8 is the correct answer. And if we create our table like this with number 4, 4, 5, 1, 3. 4, 5, 1, 3. This is the thing. And now we create a table. I think this has to be two-dimensional. To and writing a recursive formula for this would be pretty easy. Like we go for the choice in which we don't allow him to get a bigger number, and choice if possible. That would be a greedy approach, right? And yes, that might backfire in some cases, a greedy approach. So I'm thinking of something more like a dynamic programming. What would be the best possible score that I get when I choose the number on left, or what would be the best possible score that I get when I choose the number on right. But the thing is, left and right are changing. Shit. Okay, recursion in the is the way to go with this. Recursion is the way to go with this. We doing this with tabulation is going to mess up because this no, we can do this with tabulation vector int vector of vector. This is going to be a two-dimensional vector, and we are going to represent the state using a f function which will take I and j, and I will be the left index and j would be the right index, and we are choosing this sub array from our original 0 to n complete array. We are only finding the answer for this sub array, and if I am at any ij, f I j recursively would be equal to, if base case would be f equal to I gen, then the answer is a bracket I. That is the best thing you could choose. And otherwise, if that is not the case, then maximum. Okay, this makes sense. Then maximum of fi plus 1 if you choose the left element, right? Or fi j minus 1 if you choose the right element. That that is just it. And also, if you did choose the left element, then you add a I to your answer, and if you choose the right element, then you add a j to your answer, and that is okay. Int, and we will start iterating from length. Yeah, length will be increasing. Res size is just, let's say, n plus 1. J will be at a maximum n minus 1, but let's just have a room vector int size and n plus 1, and let's fill the base cases. So for int I equals 0, I less than n, I plus plus, res I bracket I equals 1, no, equals ai, and now for int L equals 2 to L equals n when the length is equal to n and I plus plus. I guess we should just have this equal to n. Now, so, and we will have res. Okay, and we will iterate through the whole thing. Int I for int I equals 0, and the right limit would be n plus 1 minus I. N plus 1 minus L minus L minus I plus L minus 1. I plus n minus L minus 1 less than n and I plus plus. So, and the right index is I plus L minus 1, and answer for left I and right is I plus L minus 1 will be equal to maximum of, if we choose the left element, ai plus res I plus 1 bracket I plus L minus 1, or if we choose the right element, which is ai plus L minus 1 plus res I bracket, if we to choose the right element, I plus L minus 2. That is how we fill the thing up. And x, what are we even looking for? Yes, we are looking for that. So the answer would be cout res from 0 till n minus 1. And hopefully that is not what I was expecting. Shit. LSP start plan D. Is there some mistake? There seems to be some mistake. Wait, why is there some mistake in this thing? My LSP does not tell me that there is some mistake with the bits library. Huh? Okay, log size is pretty big, but that is not a problem. We're using lang D. LSP stop it. Okay, vector and G++ removal again. Okay, there is literally some problem then. This is two-dimensional, so no match for operator. This, why? Wait, shit, what even is that? What was that? I++? Yep, I am, yes, makes sense. Okay, let me go to the washroom and I'll be right back in a minute. Order is 3451. Huh? Okay, I'll be just right back in a minute. Order is 3451. Yeah, so Alice goes with 3, then Bob goes with 4, then Alice goes with 5, then Bob goes with 1, and Alice has 3 and 5, and Bob has 4 and 1. Yep. Okay, so somehow this thing just keeps on going forever. I plus plus less than equal to n. Yeah, wrong answer somehow. Okay, I for auto x n res c out x. Correct answer is 8, and 8 is nowhere to be seen in this matrix. 4, 9. If our length is, we no, 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 no. Shit, I'm just adding everything up here, right? Yes, shit. We cannot have every number. Okay, so this recurrence is kind of wrong. When I am here, current number plus when range is 2, say 1 and 4, I have only these two numbers. Then if I choose this one number on the left, I will have this plus, what is the highest possible value in this? The highest possible value in this would be given to the other person. Yes. And I would have to add, okay, I can have a prefix. Yes, okay, I will have a prefix, and I will find the sum of this range, and whatever the maximum possible value is for this, I first will say S is the sum of this whole range, which in this case is 5. 5 minus what is the best possible value that the other person can have from this subarray, which is 4 in this case, minus 4. So my answer here would be 1. Okay, so I have to find the prefix for this. vector in ref n plus 1 for int I equals 0, I less than n, I plus plus, ref I plus 1 equals ref I plus ai. That is kind of it for prefix, and here we will have to change this thing res I j equals maximum of, if we choose the element on the left, then pref what is the sum of this range. Okay, and we should also make this thing a long just in case, not just in case, we should actually make this thing a long, and yes, that would suffice, I hope. Shit, xi could be negative even. 5000 10 power 9, yeah, long will suffice. And if we go with the element on the left, let's first of all see what the prefix is going to be, the sum is going to be. Wait, I should change everything to a integer because we are looking for the sum, and sum can be a big value. Long, and yes, long sm will be equal to pref I plus 1 is going to include that number, and our range goes from I plus L minus ref I. I is also included. And on the right, yes, this is cool. So that is our total sum. And if we go with the first element, then what we will get is sm prefix minus res I plus 1 j. Yes, comma s. Otherwise, if you go with the right one, then res I j minus 1. I think this might be better than before. J was not declared. That does make a lot of sense. The right index is I plus L minus 1. In this case, it is I plus L minus 2. Where am I using G? Okay, 8. We do get 8. Correct. Cool. This is working. This is working. We can remove this debugging part. I think that is cool. That does work. That seems to be cool. And now what we can do before submitting and testing, if this is correct, is of course rewrite the whole solution. And what are we getting? N, C in N, and then we will create a vector in or long, let's say a size n, and we will take in the input in a, C in x, and now we will create a response array which is going to be two-dimensional vector and long, because it is going to involve sums of very big numbers. So long, and size is going to be n, and yes, long n. And let's fix the base cases I0, I less than n, I plus plus, or the base case rest I equals AI. That is something that we need. And we also need a prefix. Array vector long ref n plus 1 for int I equals 0, I less than. Now we have to fill this prefix ref I plus 1 equals. Okay, let's make this more human readable. Int I equals 0, I less than n, I plus plus ref I plus 1 equals ref I, the earlier value, plus AI. And now our prefix is also filled. Now we will iterate with length starting at 2, and length will never exceed n, and it will keep increasing till then. And internally we will start iterating from I equals 0, while the right index would be L, would be I plus L minus 1, because I should also be included, the ith number. That is why go to the next L minus 1th number. This thing has to be lower than n and I plus plus. And then for response I comma left, and the right limit is res, right limit is I plus L minus 1. This thing is equal to the maximum. First of all, what is going to be the sum in this range of prefix? Sm equals ref the right index of the right element plus 1, because we want to include the right element, minus ref I, the left element. And here Sm minus the best value from when we choose the left element. And if we do choose the left element, we're looking for something like this, I plus L minus 1. And if we do choose the right element, then the answer would be prefix sum minus the best value that the other person is going to get if the remaining array does not have the right element, which is I comma I plus L minus 2. And when this table is filled out, see out starting from 0 going up till n minus 1 index, what is the best answer possible, which is it, what, yes, long, my bad. And that is correct. Let's see if it actually is correct or it is just in our head. What even is the name of the question? Removal game. R. Removal game. Submit. Okay. Okay. Shit. Yes, we win these. Okay. That is cool. That is cool. How many have we done? And how many are remaining in the dynamic programming section? And my goal was to complete all of this till Sunday. Yesterday, I was unable to do anything. But okay, I will do my best to meet that goal. Minimal grid path seems like something I've read about in the C. I think there is minimal grid path question in that competitive programmers handbook. But why have only 2,400 people able to do this? Should this? No, this is the hardest question. Mountain range. And now there are only difficult questions left except this. I don't know why. I think I'm not even using dynamic programming approach in this one because I'm getting time limit exceeded error here. Yeah, a long way. We just did. We have done rectangle cutting towers. The one that we just did is called a removal games, which is this one. And yeah, and it has been 3 hours and 40 minutes. And for today, we only did 2 questions, but we did we gave more than 2 hours, 2 hours and 30 minutes. I would say even 3 hours. Yeah, I guess we gave out 3 hours for the first question, but we were able to do it. So that is pretty nice. And for the second question, we were able to do it in about 40 minutes. So that is nice. And we are making progress. That is cool. And for today, that would be the end of the stream. And thank you for being here. Bye.